deepfake style transfer mixture, a first forensic ballistics study on synthetic images. Abstract. This paper describes a study on detecting how many times a digital image has been processed by generative architecture for style transfer. Moreover, in order to address and study accurately forensic ballistics on deepfake images, some mathematical properties of style transfer operations were investigated. Introduction. Advances in deep learning algorithms, and specifically the introduction of generative adversarial networks (GAN) architectures, enable the creation and widespread of extremely refined techniques able to manipulate digital data, alter it, or create content from scratch. These algorithms achieve surprisingly realistic results, leading to the birth of the deepfake phenomenon, multimedia content synthetically modified or created through machine learning techniques. Deepfakes, or also called synthetic multimedia content, could be employed to manipulate or even generate realistic places, animals, objects, and human beings. In this paper, only the most dangerous deepfake images of people's faces were taken into account. Specifically, the manipulations on people's faces could be categorized into four main groups: entire face synthesis, attribute manipulation, identity swap, expression swap. Forensic ballistics on deepfake images. In order to define whether a multimedia content has undergone one or two deepfake manipulation operations belonging to the style transfer category, the research paper considered two approaches. A first analytical approach, method one, in which the DCT coefficients were analyzed to study whether there are discriminative frequency statistics. Given the potential of deep neural networks to solve different deepfake classification tasks, our second method relies on the use of a basic encoder, ResNet 18. Method 1. Let I be a digital image. Following the JPEG pipeline, I is defined into non-overlapping blocks of size 8 into 8. The discrete cosine transform DCT is then applied to each block, obtaining the 64 DCT coefficient. By applying evidence reported in the DC coefficient can be modeled with the Gaussian distribution, while the AC coefficients were demonstrated to follow a zero-centered Laplacian distribution described by the following equation. With mu is equal to 0 and beta is equal to sigma upon root 2 is the scale parameter where sigma corresponds to the standard deviation of the AC coefficient distribution. The beta value defines the amplitude of the Laplacian graph that characterizes the AC parameters. It is possible to analyze all beta values to determine if they can be discriminative to false the proposed task. For this reason, the following feature vector was obtained for each involved image. Method 2. The PyTorch implementation of ResNet 18 was used starting from the pre-trained model trained on ImageNet 5. A fully connected layer with an output size of 2, followed by a softmax, were added to the last layer of the ResNet in 18 in order to be trained on the specific task. The network is set consider the following parameters. Batch size is equal to 30, learning rate is equal to 0.0001, number of classes is equal to 2, epochs is equal to 100, criterion is equal to cross entropy loss, optimizer is equal to SGD with momentum is equal to 0.9.
Creating datasets for both methods. Deepfake 2 representing all images where a style transfer operation is applied once. The 2 in Deepfake 2 class label refers to the input number, the source, and the target. Thus, we collected a set of images D1 where S1 and T1 represent two different datasets. Deepfake 3 representing all images where a style transfer operation is applied twice. Thus, we have collected a set of images D2 where D1 is the source representing the output of the first style transfer operation. Experiment results. This paper collected images generated by star GANV2 because it is the best style transfer architecture capable of obtaining deepfake images with high quality detail and resolution. For the methods described above, 1200 images were considered as a train set and 200 images as a test set for each class. So in total, a train set consists of 2400 images and a test set consists of 400 images. Having demonstrated the high accuracy results obtained in the classification task, it may be useful to understand for complete and accurate forensic ballistics analysis on deepfake images whether mathematical properties of the style transfer operations are satisfied. The above figure shows examples of images generated by STAR GAN V2 engine. In the first section of the images, in which a style transfer operation was applied once, and the second part, images in which a style transfer operation was applied twice. Over here, there are some results. The table shows classification results of the proposed analytical method. Training accuracy values and loss values were shown in the ordinate axis in A and B respectively, calculated over 100 epochs of deepfake 2 and deepfake 3 class images. The best accuracy was 92.75% with a loss value of 0.23. These are few of the mathematical properties applied. Let A, B, and C be three input images, and these are the three properties where phi is the neutral element. So here first property is used. Style transfer operations S and T represent the source and the target respectively. In the figure A, the source are images of people's faces and the targets are total black and total white images. Figure B shows the source and target are the same images. Property 2 is applied in this figure. Style transfer operations related to property 2, where H represents the function that computes the RGB histogram. Style transfer operations related to property 3, here H represents the function that computes the RGB histogram. In conclusion, this paper proposed a first approach to investigate forensic ballistics on deepfake images subjected to style transfer manipulations. In detail, they tried to define if a synthetic image has been subjected to one or two deepfake manipulation processes by proposing two possible methods, one purely analytical and another based on a deep neural architecture. To better understand the type of style transfer manipulation, we also demonstrated several mathematical properties of the operation itself. Future scopes. This study represents a good starting point to create more sophisticated methods in field of forensic ballistics of deepfake images. In future works, we will address this issue considering also other different manipulation, example face swap, and we will try to generalize as much as possible also on audio and video deepfakes. These are few of the references for the research paper given below. Thank you very much.